Assalamualaikum and hi everyone. We are from group 3. We will discuss about semiconductor industry. Before going further, I will introduce our group member. The first picture belong to Jakan. The second one is Lee Yuet Yu. The third one is me, Nufarisha. Next is Mazlan and lastly is Muhammad Istaufik. For introduction, the semiconductor industry is a sector of the electronic industry that focuses on the design, development, manufacturing, and sale of semiconductor device. Semiconductor are material with electrical conductivity between conductors such as metal and insulators such as plastic and rubber.
I'm Li Yu. I will explain about the product design. An analog front-end IC has been selected as the product for this case study project. An analog front-end IC transforms analog sensor output signal into digital signals, that's digital signal processing, and outputs to the host through the digital transmission. Product specifications are shown in a table. 1,000 quantities of the IC need to be produced, and it needed 1.5 months to produce it.
Good day, Dr. Remy. So I'm going to explain today is on the process design. So these are the tools that are needed to accomplish the analog front-end IC. So the tools is bill of material, assemble process chart, process flow chart, and also root sheet. So bill of material, also known as BOM, is basically required, also known as the material required to accomplish the product. So for here, the material needed is start from OP, AMP till to the LED. So for next, these are the assemble also process chart. So from here we can observe that each stage the part will be processed according to the different stages of department. So from here we can see that oxidization, photolithography, and also etching are considered to be in a one process in one department if compared to the others. So the purpose is to occur rework and also to found any defect during the process. So next, these are the process chart. Is an overview from initial stage until to the end customer. So these are the flow as a image flow of the process. So for root sheet, so the purpose of root sheet is one documentation and also reference is to provide essential information about the specific task, requirement, and specification associated with the stage, accurate, and also efficient. So next is tracking and control, is to monitor the progress of each stage of the production process by providing information of specific task, requirement, facilitating accurate and efficient execution.
Hi, I am Mazlan. Today I will present about schedule design. Schedule design is to allocate resource operation and process, balance client requirement and available resource, ensure cost effectiveness, enable timely manufacturing and delivery, crucial for efficient operation. There are 5 components to schedule design. First is resource allocation, assigning resource effectively to production activities. Then operation sequencing, determining the order of tasks to optimize workflow. Then time estimation, predicting the duration of each activity. Then priority setting, establishing the importance of different tasks. And finally, schedule monitoring and control, continuously tracking the progress and making adjustments as necessary.
Hi, I am Is. I will explain about type of layout. So, this semiconductor factory use a cellular layout is a manufacturing layout strategy that involves dividing the production area into self-contained work cell. Each work cell is dedicated to a specific set of tasks of operation within the production process. The cells are organized in a way that minimize material movement and optimize the flow of work.
Product tree structure. Product tree structure is a hierarchical representation of product, breaking it down into component and sub-assemblies, and it's aid in production planning, inventory management, and understanding manufacturing process. Still quantity of the production. First, we assume the total demand is 1,000 units, and the defect rate and rework rate is as shown below. First operation we get 1,031 units. For second operation we get 1,058 units, and third operation we get 101 units. Material flow system. Basically, material flow system is automated the transfer of material in semiconductor manufacturing. Then, ensure efficient movement of raw material for final semiconductor production. Then, minimize overall flow and associate costs. Involve automated process and pathway in semiconductor fabrication. This is the material flow system. First, they have automated material handling, conveyor system, robotic and AGV, material tracking system, and Kanban system. This will help to minimizing total flow and minimizing the cost of flow.
So for activity relationship, it is highly structured and complex manufacturing flow involving multiple steps such as wafer fabrication, device assembly, testing, and packaging. Each of these activities is interconnected and change in one process can affect subsequent process and the final product. Understanding the optimization and the activity relationship is crucial for achieving high quality semiconductor device and efficient production.
Material handling refer to efficient and safe handling of raw material components, work in progress item, and finished product. So the first one is industrial robotic arm. Analog front end IC have resistor, capacitor, so these components are mounted and handled onto the IC using the industrial robotic arm because they are tiny and small. The next one is rack and shelving system. In materials such wafer, mass, and chemical must be stored in cabinets, rack, and specialized container.
Alright, I will explain about layout planning. So we have 2 floors for the factory, and I will explain about the floor that is compliant with various design rules and constraints specified by the chip fabrication process. This rule dictate minimum spacing, width, and other geometrical consideration for different component and interconnect. The floor plan should adhere to this rule to ensure manufacturability and yield. Efficient utilization of the chip's area is vital in floor planning. Shrinking the chip's footprint reduces manufacturing costs and allows for a higher level of integration. Designers optimize the placement to minimize the overall chip area while accommodating all necessary components and meeting performance requirements.
Next, I will explain about the personnel requirements. The planning of the personnel requirements includes plannings for employee parking, restroom, health service, and food service. In this case study project, 19-angle parking is preferred. Next is the restroom. The purpose of the restroom is to offer the employee access to area where individuals may take care of their physical requirements in a clean, secure, private, and sanitary way. Total 260 employees, hence, the number of the water closet is 8, while the number of the lavatories is 13. Then health service. To improve productivity, maintain a safe working environment, and promote employee well-being, a facility must offer health service such as first aid treatment. The room is 250 square feet as it requires a nurse. Last, food service. Service area. The serving area should be planned to allow for effective flow and queue management. Dining area, wheelchair accessibility, high traffic areas, and any unique requirements for various dining groups, such as family, singles, or big groups should all be taken into account while planning the layout. Last, kitchen area. It should have separate design for food preparation, baking, cooking, storage, and washing.
For manufacturing system, fixed automation typically involve a series of repeated or constant procedures such as manufacturing or the processing process, which means the fixed automation is specialized to generate a certain kind of product. So based on our project, we have chosen one product, which is analog front end IC. For a fixed automation system, it has 3 transfer lines. Transfer line is a line flow structure starting from the input into the outputs. Based on the layout used in Waisala, the company we have chosen, is it show that the U-flow transfer line is used.
Enclosure system. The enclosure system is include a facility like clean room, temperature, humidity, air quality, and contamination are controlled by it. Safety, functionality, and industry compliance are ensured. Basically, shown is the facility need to be added in a semiconductor facility to complete the enclosure system.
Electrical and lighting system. In an electrical and lighting system, we have 8 steps to follow. First, the level of illumination. Second, the room cavity ratio, RCR, is used to evaluate how well a lighting fixture is in a room perform. The RCR we calculate is 2.4. Then, the ceiling cavity ratio, CCR, is 1. Then, wall reflection and effective ceiling reflectance. We use white paint for base ceiling while medium color paint for wall. So we can get the ECR is 67%. Fifth, the coefficient of utilization. As mentioned above, RCR is 2.4. The wall refraction is 80% and the ECR is 67%. Hence, we can know that the CU is 0.6. Next, light loss factor. We assume the watts of a fluorescent lamp in prismatic lens fixture is 59 watts. Then, the number of lamps and luminaire. We assume one lamp is placed in each luminary. Hence, we can calculate the number of luminaries in the clean room and we get 2 luminaire. Lastly, the location of the luminaire. By doing the previous step, the illumination level within the room will be evenly distributed and will be adequate to perform the task within a clean room of the semiconductor industry.
So for the discussion and also recommendation, I have highlighted into some points. So first of all, we're going to take a look in discussion. So the first point is to highlight the inherent risk posed by the hazardous material, high temperature and complex machinery, emphasizing the need for safety protocol, emergency response plan and employee training. So for the next about the equipment selection should be essential to minimize the operational efficiency, minimize the production downtime and also to ensure the smooth material flow. And for sustainability and environment factor is to implementing energy efficient system, adopting proper waste management practice by using environmental friendly materials that can be helped to reduce the environment impact for the semiconductor. So for the recommendation, I've highlighted into 2 points. The first is to with a modular design concept and also it adaptable flow plan enables the efficient expansion and also adaptability to be changing needs. So the second point is to optimize the material flow by minimizing the travel distance, implementing automated handling system and also improving the storage and inventory management. So that's all from me and also from our group. Thank you.